So we're going to go ahead and take a look at this first ideal gas law practice problem. The ideal gas law is the only law within the set of gas laws that has moles in it or allows you to calculate for moles. So if you're ever asked to find moles, if you're given moles, if you're asked to find grams or you're given grams, the ideal gas law is what you'll need to use. Now the ideal gas law is PV equals nRT, which I call PVnRT to help me remember what variables are in there. And so we've got pressure, we've got volume, we've got moles, we've got R, and we've got temperature. Whenever I'm doing a gas law problem, I always start this way. I always go ahead and write down the equation that I'm going to need. I then write down the variables. Now, sometimes I start by writing down my variables because I'm not sure which equation I need yet. So let's go ahead back and look at this problem we have here. It says if there are 4 moles, well, that's N, at a pressure of 5.6 atmospheres and a volume of 12 liters, what is the temperature? So we're looking for temperature. Now, all of the temperature units when you're doing gas law problems must be in Kelvin. You must always convert to Kelvin, so our temperature should always come out as Kelvin as well. Now, this R value is dependent on which units you're using in your problem. So in this particular problem, if you go back and look at the slide on the R values, you'll see that there's several different R values. The only difference is their type of units that they have. So for us, because we have atmospheres, we're going to have to use that first R value, which is 0.0821 liters times atmospheres over mole times Kelvin. Now, this is just a unit. We do not multiply or divide or do anything to that R value. This is simply a unit that goes with the constant R. And that is, in fact, the gas law constant. So now that we have everything, we can kind of plug things into our equation. So we've got pressure, which is 5.6 atmospheres, times volume, which is 12 liters, equals 4 moles times our R value, 0.0821 liters, atmospheres, mole K. And I'm running out of space here, so times our X value, which is in Kelvin. Okay. Now, I almost prefer to rearrange the equation first and then solve the problem, but I know a lot of people just like to plug in the values. So we'll go with plugging in the values here. So 5.6 times 12 liters gives us 67.2, and the unit here is going to be atmospheres times liters because that's what we did, right? We multiplied the two units. We're going to set that equal to now the 4 moles times 0.0821. That gives us 0.3284. And if you look here, moles is going to cancel in the unit there. So we get liters times atmospheres over Kelvin times X. Okay, so now to get our X by itself, we're going to divide both sides by the 3.3284. And so I need to grab my calculator here. Hold on. 67.2 divided by 0.3284. And you should get 204.6 and lots of numbers. I'm just going to round that to the third or fourth decimal place just to keep things easy here. And so dividing those two, we get our X value to be 204.6 Kelvin. So that's kind of hard to read, sorry. 204.6 Kelvin. Okay. So this is our answer. This is the temperature. If you wanted to get it in degrees Celsius, if the question asked for it in degrees Celsius, you could just subtract 273 from that. But the ideal gas law is made so that you can take a set of conditions, and if you're missing one variable, you can solve for that one variable.